we're going to go back to chapter 5 and move on to section 5.4. Section 5.4 is dealing with complex numbers. You may also hear them called imaginary numbers. It's the same thing. Back in Algebra 1, we talked a lot about real numbers, didn't we? Everything is a real number. Any number you've ever worked with has to be a real number. In other words, you could pinpoint that number on the number line. If it's a real number, you could calculate whatever the decimal value is, and you could put it on the number line if you have to, couldn't you? Complex numbers are not that way. They are not numbers on a number line. I know that seems complex in itself, but they're not numbers that we can put on a number line. Complex numbers are going to be numbers that are imaginary. We can't see them. We can't put them on a number line. We are going to simplify some expressions that contain these complex numbers. The first thing you're going to want to write into your notes is what an imaginary number is. Here at the top of this slide it says imaginary number I. I is the variable that we use to represent an imaginary number. Anytime you have something like 6i or negative 2i, or it says I square root of 3 down here, we know we're dealing with an imaginary number, also known as a complex number. If it has an I, it's imaginary. Please make a note in your notes. These two bullets right here, these are very important. These are things you're going to need to know. If you have I squared is equivalent to negative 1. Not I, but I squared. The square root of negative 1 in the second bullet is equivalent to I. I squared equals negative 1. And I is equal to the square root of negative 1. Those first two bullets are very important to make sure that you are aware of. If you see those, you know what their equivalent is. So let's simplify some expressions. Here we have the square root of negative 28. I want you on your calculator to take the square root of negative 28. So second square root, negative 28. Make sure you put the negative underneath the square root. Did you get something like I got, an error message? My error message is that it's a non-real answer. Well, if something's non-real, not real, it is imaginary. We have an imaginary number here that we're going to need to simplify. So if you're ever unsure if you're dealing with imaginary number, type in your calculator, it'll tell you. The square root of negative 28. We know that negative 1 times 28 is negative 28, correct? Okay. We learned about the product property of square roots a couple of days ago. We know that we can break this apart and give each number its very own square root. Just a few minutes ago, we learned what the square root of negative 1 is. What is the square root of negative 1? I. Didn't we just think of that on the last slide? The square root of negative 1 right here is equal to I. So I'm going to replace the square root of negative 1 with I. We have an imaginary number in our answer. Now the square root of 28 can be simplified. There's a number that goes into 28 that's a perfect square. What is that? 4 and 7. So using our product property, we can break apart the square root and give each number its own square root. So we have I times 2 radical 7, or square root of 7. I don't want you to leave it as I2. Think of I as like a variable. We want to put our variable after our number, correct? So we're going to write this as 2I square root of 7. 2I square root of 7. We want it after our number, but before the square root. Let's look at another one. The square root of negative 32. If we were to type in the square root of negative 32 on our calculator, we're again going to get an error message, a non-real answer. What part of this is giving us an error message? The negative underneath that square root. You can't have a negative under the square root and get a real answer. So let's use our product property. We know this is negative 1 times 32. We can break this apart and give each number its own square root. The square root of negative 1 is equivalent to I. And 32, I believe, can be broken down. There's a number that goes in that's a perfect square. Good, Maddie. 16 and 2. Square root of 16 times 2. So break apart your square root of 16 times the square root of 2. We know the square root of 16 is 4. And I do want to rewrite this and put the I after the number 4I square root of 2. How about this one, the square root of negative 125? If you were to type this into your calculator, what are you going to get? You're going to get an error, and we know that because we have a negative under the square root. So let's go ahead and break it apart and simplify this complex number. We have negative 1 times 125. Using the product property, we can break it apart and give each number its own square root. The square root of negative 1 is really I. 125, can that be broken down? Right. What number goes into 125 that's a perfect square? 25 and 5. So in our product property, we're breaking it apart again. We know the square root of 25 is 5. We have 5I square root of 5. I have a couple of additional problems that are multiple choice that I'm going to ask you to simplify. I'm going to go ahead and put it up here on the board. If you would grab a clicker real quick, you will need it to send in your answer. We need 2 more people in. One more. Make sure you hit send on your clicker. I won't send. It's in grab a number. Let's put that one on my desk. Go ahead and hit stop. Very good. Everyone got the correct answer. Excellent, guys. Square root of negative 50. That's really negative 1 times 50. I, square root of 50. Break apart 50. 5i square root of 2. Excellent job. Do you feel like you need another one, or are you good on these? Everybody got it right, so just really another one. Go ahead and move on. These next expressions don't necessarily contain square roots, but they are going to contain imaginary numbers. Treat it like a variable. The same rules for multiplying variables apply to imaginary numbers. Think of I as its own variable. So we have negative 3i times 2i. You can multiply variables, can't you? Yeah, we can multiply coefficients. Let's start by multiplying. Negative 3 times 2 is negative 6. And I times I is I squared. Now we can simplify. This is not in simplest form. We learned earlier today what I squared is. Negative 1. Right here we learned that I squared is equal to negative 1. So I'm going to replace I squared with negative 1. So continue to multiply. Negative 6 times negative 1 is positive 6. Here we have negative 5i times 3i. Again, we can multiply our coefficients, we can multiply our i's. Negative 5 times 3 is, of course, negative 15, and I times I is I squared. We know I squared is equivalent, is equal to negative 1. So negative 15 times negative 1 is positive 15. Thank you very much. You're welcome. I would like for you to try this one. Simplify that expression, please. Are the batteries dead or just not working? Excellent. Most everybody says B here. 3 times 5 is 15, and I times I is I squared. We know that I squared is equivalent, so negative 1. So 15 times negative 1 is negative 15. let's move on to some different problems. These next couple of problems are going to have square roots. They're also going to have imaginary numbers. And we're going to be multiplying those imaginary numbers. Kind of putting everything together. You need to simplify each square root. Let me ask you something real quick before we even jump into this. This first number is imaginary, isn't it? We know it because that's a negative under the square root. The second number is imaginary, isn't it? It's a negative under the square root. Now, if we were to multiply at the very beginning and take negative 12 times negative 2, that's going to give us a positive 24. Is positive 24 an imaginary number? We lose that imaginary number if we multiply up front. You do need to simplify each expression, and then you can multiply the results. So let's start with the square root of negative 12. Of course, we can break that down into negative 1 times 12. Square root of negative 2, we can break that down into negative 1 times 2. Use the product property and give each number its own square root. The square root of negative 1 here is I. Now the square root of 12, can I go ahead and break that down? What goes into 12 that's a perfect square? 4 and 3. I'm going to apply the product property again here and give 4 and 3 its own square root. Just bringing everything else down for the time being. Square root of 4 is 2, so I really have 2i square root of 3 times I square root of 2. Now we can go ahead and multiply. I have 2. I times I would be I squared. And the square root of 3 times the square root of 2 is 6, square root of 6. Now let's replace I squared. We know I squared is really negative 1. And 2 times negative 1 is negative 2. Negative 2 square root of 6. We would not have gotten that negative 2. We would have gotten 2 square root of 6, but we would not have gotten negative 2 square root of 6 had we multiplied at the very beginning. Had we multiplied that the 12 and the negative 12 and negative 2. It's important that you simplify first, and then you can multiply your results. Let's look at another one like this. Square root of negative 20 times the square root of negative 12. Again, I don't want to multiply negative 20 and negative 12 because that will lose my imaginary number. Let's start by breaking it down. For negative 20, we know that's negative 1 times 20. And negative 12, we know that's negative 1 times 12. Using the product property, we'll give each number its own square root. I'm going to use my product property once again here. I'm going to actually change these negative 1s, square root of negative 1s, make those i's. And 20 can be broken down, square root of 20 can be broken down into the square root of 4, square root of 5. And 12 can be broken down into the square root of 4 and the square root of 3. Let's simplify here. I have square root of 4, which is 2, so 2i, square root of 5. Square root of 4 here is 2, so I have 2i, square root of 3. Now we can multiply. Multiply your coefficients and multiply the numbers underneath the square roots and multiply your imaginary numbers. So 4i squared, square root of 15. Of course, I squared is really negative 1. 4 times negative 1 is negative 4, square root of 15. This next one is a multiple choice problem that you can send in using your clicker. you would go ahead and simplify, please. We're almost finished. We've got, counting this one, we have 3 problems left. This one and 2 others. Sorry guys, I didn't stop the clickers. There you go, now you can send in your answer. Sorry about that. I need one more in. There it goes. Good. Most of you said B. Looks like a couple of you said A and C. So let's look at this. Again, don't multiply -2 and -6 because that's going to give you a real number, and we are going to have an imaginary answer. Or potentially could have an imaginary answer, I should say. We have -1 times 2 in the first square root. In the second square root, I'll break that down and say -1 times 6. Use our product property to break square root down again. I square root of 2 times I square root of 6. I times I is I squared. 2 times 6 is 12. Now I can't leave it at square root of 12 because there is a number that goes into 12 that's a perfect square. Of course, that's 4 and 3. We can replace it any time. I squared is really -1. Square root of 4 is 2. So -1 times 2 is -2 square root of 3. Just let it. All right, we have 2 more problems to look at. These look really simple to start with. I to the 5th power. They're wanting you to simplify. I don't know what I to the 5th is, do you? But we do know what I squared is, correct? So think in terms of I squareds. How many groups of 2 can I make if I've got 5 i's? 2. Think of it this way, 5 divided by 2 be 2.5, right? I can make 2 full groups. But I'm going to have 1 I left over that doesn't make a group of 2, aren't I? I times I times I times I to the 5th power. How many groups of 2 can we make? Well, we can make 1. 2 groups of 2, but we still have that 1 I left over, so I need to multiply by that 1 I that's left over. So at this point, we just simplify. What is I squared equivalent to? -1. Now I need to take -1 squared. -1 times -1 is +1 times I, and 1 times I is 1I. If you wrote it as 1I, that would be the same thing. Let's look at another one like this. One more here. I to the 12th power. We don't know what I to the 12th is, but we do know what I squared is. So think how many groups of 2 can you make if you've got 12 i's? Or think 12 divided by 2. 6. I can make 6 groups of 2. We know that I squared is really -1. So -1 to the 6th power. If you're unsure, you could type that into your calculator. Please use parentheses. Parentheses. -1 caret 6. Which is 1. And if you're going to use your calculator, make sure you do put it in parentheses. Alright, so these complex numbers are just a new way of thinking. I want you to think of that I, it's kind of like a variable. The rules as far as multiplying variables still apply. We're kind of putting some things that we've done previously as far as simplifying square roots. Putting that in with our imaginary numbers. The homework problems for today are going to be out of your book. They begin on page 280 and I think they go on to 281. Numbers 1 through 6 and 18 through 25. If you need to borrow a textbook, you may, but I do ask that you trade me just something for collateral. Just bring it back.